Hey everyone, I'm Doug Craig with Lord Fusor.
I'm Dennis Beardsley with St. Gobain.
We're here tonight to talk to you about sealing. Kind of an open topic in cars. There's a lot of different areas during collision repair. We need to do sealing, and that's what we're going to hit you with. We're going to look at doing some weld sealing, so not weld bonding, but weld sealing. I want to talk about the prep that we're going to do, and again, follow OEM guidelines. We'll look at different kinds of laps and or standardized seam sealing. In particular, we'll focus on the rear body panel on this vehicle, but we'll talk about others. We're going to look at one component seam sealer using different kinds of spreaders. We're going to look at 1K sprayable product, different kinds of beads that we can make with that. We're going to take some two-component materials, we're going to tool them, spray them, give you some real cool tips on the self-leveling materials. Then we'll look at additional corrosion protection, another kind of sealing where we're talking about cavity wax and underbody protection. Then we'll wrap it up with NVH, and I'll get to that definition a little bit later on, but we're looking at air movement through the vehicle, through pillars, and sound control in general. One of the most important things is to follow OEM guidelines, right? It's been one of my campaigns all this year. You got 3 simple rules. Follow OEM procedures, follow OEM procedures. Rule 3 is reflect back on rules 1 and 2. Follow those OEM guidelines, right? The information's out there, look for it. So we are RSG, Refinish Solutions Group.
Yeah. So a lot of people ask, what is that? St. Gobain has the 3 brands, Norton, Carborundum, and Solar Guard. We're a sandpaper company, but to collision centers, we have to be more to that. So our idea is to be a one-stop shop. Right. We want to be everything but the liquids on the car.
Perfect. So we've got American tape. We've got DeVilbiss, so we got spray application equipment.
Fusor.
We've got Fusor, the adhesive experts, and we got Mothers, polishes, wax, and cleaners. Yep. That's a pretty well-rounded portfolio. But tonight, the focus is sealing applications. And why do we seal? We seal roof ditches on cars, right? That's a wet zone. We want to keep the water out of that joint, and it's a strange joint. We do lap sealing on panels of varying types. We seal up doors and hoods and deck lids where they've got hem flanges. And in some areas of the car, you see a lot of different kind of looking beads now. Robots create this. It's up to us to try and repair it. I'm going to use some jargon tonight, and I don't always think about it, but let's talk about when we say 1K and 2K, what did we really mean? In German, component with a K is what we talk about component in English, so it means a part. So when I say 2K, it's just one of those terminologies came out of Germany years ago. I'm talking about putting A and B together through a mixer to create a product. We're going to have a chemical reaction at that point. That's how they work. A and B get together, and then things happen, I'll say quickly. So we're not waiting for something to happen. There's no drying, there's no flashing. It's a chemical reaction.
Cures.
It cures, exactly. The most important part, playing with 2K products, is not even picking the rice product, right?
Level and purge.
The packages come, the pistons are almost always somehow a little bit askew. You always want to push a little bit of material out till you get A and B at the top of that cartridge, right? Put your mixer on, get ready to do your work. Then, just before you start the work, you're going to do a run out. So we're going to run a little bit of material through the mixer, maybe 2-3 inches. That ensures it's all mixed up. Look at it. If you see lines and stripes or strange colors, run out a little bit more until it's a nice, consistent bead.
I've been asked this. Do you have to keep going? So you use that brand new tube, you use out that material, you hang it up. Do you have to repurge again?
You're always going to purge the mixer. Theoretically, the cartridge should be leveled. Take a second and pump out just a little bit, because you can get some contamination and curing down through the various components. It's just it happens, right? Just want to make sure that we've got clean A and B. but you always have to purge the mixer every time. It's swirling through there, it's mixing initially, and then it's mixing more. Make sure that what's coming out the end is actually mixed together.
I've also heard if I just gun out a little bit more, it will fix itself if the level is off.
If you started off without leveling the pistons, when the material first comes out, it'll be either the A side or B side. You just polluted the mixer. All right, it's full of one. I can't tell you how long it may take, if it will ever actually become like a 1-to-1 mix or a true 2-to-1 mix, depending on the package. If you make the mistake, and I do it regularly, you forget. You're just in a hurry, throw the mixer away, pop it in the mixer on, run it out, go to town. Don't worry about it. Hey, Dennis, we've got our first call-in question. Looks like it's Steve from Shreveport. Steve wants to know, how do I know that the product is still good to use?
That's a good question. So on the back of the tube, it'll say manufacture date. So this one was July 2018 and best used within 24 months. So we're good to go.
That's pretty simple. I don't need a decoder ring to understand that?
Not this one.
Wow, okay. Thanks, Steve, for the question.
Yeah, thank you.
So weld sealing. Weld sealing is a newer process where we're mixing one component, seam sealer, with resistance spot welding. STRSW, as it's called by many, squeeze type resistance spot welding, AKA spot welding. That's all we're talking about. So we're doing those welds that are the primary builder of a car, a steel car. Aluminum cars, you're going to see rivets and other items, but in a steel car, it's spot welding. In the field, that's what we really want to be fixing a car with. Most of the manufacturers are all on board now. You do spot welds. The only place you don't do spot welds is where you can't access it because you can't get the arms or tongs in there. Or maybe you're doing a butt joint, some kind of a sectioning location. Then we're going to use other welding options. But the sealer provides us with corrosion protection. Our DTM product is direct to metal. It's designed to go to bare metal. It'll stick to paint, e-coat, bare metal. It'll protect it. Once that joint is sealed, what have we done? We've made sure that fumes, gases, liquids can't flow in and out of the car. Right? We want to keep the conditioned air inside the car, and we want to keep what's outside the car, outside the car. We want to keep it from rusting out, corroding. And in some cases, there are what are called rat holes. Rat holes are just bigger holes in the body structure that are all part of different panels fitting together and with build tolerance stack up. So as you're building a car, a millimeter could end up with a 3 or 4 millimeter hole. Well, they work perfectly great to cover those up and seal them out. But what you'll never see weld sealing in a structural area. It'll either be straight welding. Nowadays, it's all weld bonded. How do you tell them apart, Dennis?
That's a great point. Right here we got a shot here of a screwdriver touching the material, and if it's squishy, that's seam sealer.
Yeah, some kind of a seam sealer.
Yeah.
Often
It's not a bonding material.
you'll see in the assembly plant they use products that are going to cure in the e-coat oven. So you'll have like a caulk-like material, we'll call it, but you may have these foamy things, and all that is a material that when it went through e-coat and got hot, gets up to near 400 degrees, it expands, it fills up voids and gaps, and provides corrosion protection. On our end, our job is to find a way to duplicate that, and you can with one component seam sealer, trapping it between the panel, oozing it out, tooling it, whatever we have to do. If you find something hard in the joint, odds are that's structural adhesive. And you refer to the service publications, you'll figure out what you're supposed to be putting in there. But in general, if in doubt,
you'll know pretty quickly.
if it's hard and they're not telling you what to do, put adhesive in there.
Yeah.
But if it's anything kind of soft, then we're going to do weld sealing or put some kind of a foam sealant in there later. One of the biggest tests that's done nowadays is in the corrosion testing world to prove that a product is good is what's called SAE J2334. So SAE is the Society of Automotive Engineers. This is where a lot of those rules for the manufacturers based in the U.S. are kept. And it's a cyclic corrosion test. And what that means is we're taking what we call coupons, samples we've created, we're putting them into an environment. One cycle is a day, and during that day period of time, we'll subject it to salt spray, 100% humidity, and raise the temperature. What you're doing, if you imagine, you're adding heat and salt to a metal joint to see how fast we can corrode it, or to see if a product can resist that corrosion. Right. In the case of the Fusor DTM, we go through 60 cycles, which is 60 days. Doesn't sound like a lot, right?
No, it doesn't.
But depending on the individual you talk to, that could be 5 to 10 years of real life.
Wow.
Done in 2 months.
Wow.
So that gives the automotive engineers the capability to look at what they're building and subject it in a short period of time to some pretty intense corrosion. And every manufacturer has their proving grounds and has their own internal method of testing. Mm-hmm. All of them rely upon some kind of a tank they drive the car through, splashing nasty, salty, icky water on it. And the salt, to be clear, used to be road salt for snow. That's what we worried about, sodium chloride. You got a new one now. Now we got mag chloride. Mag chloride is cheaper, it's greener. This is the one that you buy if you have dogs. Put it on your walkway so it doesn't make the dog's feet hurt.
Right.
Well, it's great for the dog's feet. It's horrible for a car and bridges. And this is where it's really becoming a point, is it's causing major industrial issues in the roadways. Mm-hmm. But we worry about fixing cars here, not bridges. So when you're doing seam sealing, you got basically 3 kinds of joints, right? You got some kind of a lap. Mm-hmm. One panel laps over another. We've got hem joints like a door, a hood, a deck lid, where you're bending and crimping over. Quarter panels now, a lot more of that. And then you get flange joints. And a flange joint's just where, imagine a rocker panel. We're mating here, but this area is not bonded. A joint's a joint. We're just trying to seal it up. When the panels are cut in production, that steel is every manufacturer is using steel with some kind of zinc on both sides. Galvanneal, galvanized, a lot of terms for it. But that cut edge is raw. Even on the service part that you get, when they e-coat it, paint doesn't like to stick to those sharp edges. So there's a tendency for that area to be light on protection. So what we do, we have to make sure, however we put the thing back together, that we're covering that up, dressing it out nicely. It's protected, right?
Yeah.
So with seam sealing, a lot of it is done with the one component, single component materials. These are materials that are ambient curing. So they just cure in the air that's around us. Basically what they're doing is absorbing a little bit of moisture, and that creates the chemical reaction. Heat has a very slight impact on that. Dry seasons in some areas really slows it down. When the overall humidity drops, then their cure times drops. But they're not drying, right? There's no solvent or water coming out.
Right.
They're absorbing to cure. That's really important to remember, and it's why we can so often paint them immediately. There's
no solvent.
There's nothing coming out.
Right.
So while it's a reaction, it's not a reaction where you're offing some kind of a solvent or a gas. It's absorbing slowly. If you need speed, and these things they'll cure about 1/8 of an inch per 24 hours. If you need faster, maybe you're doing a door skin and we want to seal up the hem flange, get it to paint, be able to cut it in, you can grab it, move it around, then you're going to want to use a 2-component material because we know how long it's going to take. It's fast, right? It's going to take minutes versus hours. But once you put the beads down, do what you want to do, right?
And you can accelerate with heat. If you want to go faster with the 2-component, put more heat on it.
True.
Where a 1-component, heat's not going to do much for it.
1 component, you're waiting. 2-component, if they aren't already fast enough, you're right, add a little more heat. good segue. Let's talk about temperature.
Critical.
Two component materials will give you on their, almost every manufacturer on their label gives you the work time, sand time, paint time, full cure time. That's all based on a temperature, one temperature. In Fusor's case, we do everything at 70 degrees Fahrenheit. Others could be 72, 75. What you need to be aware of is that if you go 20 degrees higher, so let's take one of my products, at 70 degrees, I say it's got 5 minutes of work time. We're down in Arizona in the late fall. 90 degrees is real common. That 5-minute product is now 2.5. So every 20 degrees up, it cuts it in half and in half. So at 110, that 5-minute product is now 1.25 minutes.
That's fast.
That's really spooky fast. But it's the opposite as well. The converse is if it's 50 degrees in the shop, it doubled. What you see in the winter, especially in the northern climates, shops may shut their heat off in the afternoon, right? We're saving energy. The other thing is if the car is facing, the repair area is facing a cold wall, it's going to be cooler. So you may see things happen slower. That can really come into play when you're doing some kind of a weld bonding on a panel where you think it should be cured and it's not, and you want to take the clamps off, or you're just mussing around. You've got to keep that temperature in mind. And so somewhere, somebody should have a thermometer in the shop.
If not, the paint department has something.
These, $1 somewhere, right? Or
Right.
free,
Right.
comes in the mail at Christmas time with something else. Just know the temperature. The relative humidity can come in and be handy with one component products, but focus on the temperature. That's the main thing that can affect things. But if we let's talk back on the one component seam sealers now. What can we do to get texture?
That's a great one. We can use scuff pads. We can use those pinking shears to cut the spreader to make it a comb. Comb it in. You can go to the dollar store, get a bunch of combs, comb out the seam sealer.
That's a neat idea. And then throw it away when you're done because it only costs you $1 for a whole pack, right?
Yeah.
Any kind of tool. What you're telling me is that whatever it is I can kind of use to create a texture is fine.
Absolutely.
Okay. And then usually you can wipe it off before it dries, right?
Yeah.
What about keeping it nice and tidy on the edges?
We can tape it off. I'm a big fan
So
of
just mask it?
Yeah, mask and then pull it off
Before it cures.
before it cures.
Good call.
Pull it off, and away you go. You want to be careful when it is warm. Going back to the two component, if it is warm, you gotta move.
Get your masking out of there in a hurry before it's part of the sealant, huh? Okay. Hey, Dennis, we got a call coming in. Tony from Chicago wants to know how to make some of these spreaders that you've used.
That's a great question. So I've got this little hole punch here, and I got this spreader, and I prefer the hole punch versus a razor blade, just so I don't cut my finger. And I do these little half right here, cutting into the spreader, and I feel like I get a nicer, smoother edge that I can comb that seam sealer nice and easy.
So don't buy them, just make them.
Just make them.
All right. Thanks, Tony. Another kind of seam sealing is spraying the one component product.
Yeah.
And I'm going to let you go on this one because this is your area of expertise.
This is fun, right? So you want to make sure that you have a diaphragm regulator. This is going to make sure that you're not going to fluctuate with air pressure. Lock that in. This thing sprays pretty darn good between 40 and 45 psi. And for the most part, you're going to stay right here adjusting on a normal spray gun. Would be close to where your fan pattern is. All the way in is very low air pressure. And you just crack it. And as you're going down a panel, you get that nice rippled bead. If you need more texture, back it out. You'll get nice ribbons. Continue on, and you'll get that nice spray spatter.
So I'm still confused about the diaphragm regulator. What about a cheater valve?
Could use one, but you're gonna you're going to short it of volume of air.
Because it's just trying to cut down the
It's a cheater.
the airflow instead of just giving you full port.
Yeah.
Okay,
I always want to be wide open throttle.
it's a good place to be. So, if you're doing a spray out with this, go back over it again for me. How do I get that swirl bead? That's always the one everyone wants to duplicate.
So as you can see, as I'm going down the panel, you can see I'm adjusting it, and you get that nice texture. As I continue out, it will be more of a spatter.
Okay. So, what's the spatter used for?
Great question. Underneath trunks, wheel wells, inside the wheel wells.
So just pretty much duplicating whatever was there.
Yeah.
What if we're going over bare metal? I mean, I know the product's great on top of bare metal. Anything you got to do special?
Yeah, so if you look at this, you'll see I'll spray and then immediately wipe it with a spreader, which is buttering it, and then I'm going to reapply the material right back over top of it, guaranteeing that I have covered all that metal.
So you're using it like a primer. You're putting some on,
Yep.
smearing it into the metal really good so that you got 100% contact, and then you're doing your texture on top.
Yes.
Okay, I got it. So something new we want to talk about, spraying two-component seam sealers. There are some rather unique seam sealers on cars now, and they're created by robots. We're not robots, so we need to find a way to do that, right?
Sure.
What you got an add-on kit here, some kind of an air injection kit, and a special mixer.
Yep. So right here, this goes on the bottom of the pneumatic gun. It goes right up here. This plugs into the tip right here. And you'll notice I have some tape on here, Doug. This tape is going to protect this fitting right here. So I put that on there, put the tape on.
So you get some spatter back now and then?
Once in a while.
Okay.
That's why I'm not paying attention. Drag it through there. What are you going to do? This can do anything. So we can put it at high pressure right here, and I can spatter the material on, or I can just put a little air, have the material come out, go down the panel like I'm showing you right here, and I can change the angle, which will change how the material looks. Also, I can go to the back. Now this is the opposite of a spray gun. So all the way out on this knob is the least amount of fluid delivery. It pushes the plungers. When I screw it in, this is going to add the speed of the plungers, which is going to give me more material. And I need to play around with this depending on the size of the bead. The more material I put on there, the bigger the bead I'm going to get. And I may be looking for that.
Okay. So big, fat, wide bead, you're gonna
All the way
ramp
in.
that up a bit.
Correct the air and go right down the panel like you see right here.
Okay. So something I just thought of, if it's cold in the shop, we want to bring that pressure up slowly. The material's going to be more viscous in the cartridge, and we don't want to have a blowout.
Oh.
If you put too much pressure, you can pop a piston. If you're one of those techs that's had too many pistons pop, look at your gun. You could have a bent rod, or you might be actually set up for a 2-to-1 application instead of 1-to-1. You got the wrong pusher on there. Just make sure, change it out. 1-to-1s will always be two the same size. If you got one big, one small, that's for a 2-to-1 cartridge. So you can also take the 2K sealers and we can tool those, right? If spraying it's not going to get us there, you want something different, then we can either put it on, leave it as a solid bead,
Yes.
just as it comes out, or however you manipulate it, right? Or we can tool it with, again, whatever. Acid brush is the most common, scuff pad's probably number 2. But I'm thinking back to that masking trick again. All right, if you want things tidy and neat, run a quick guideline with the masking. That makes it pretty easy, and it just popped into my head. I've been hearing a lot about people like doing wheel arch sealers, and they'll do them off the car on tape, and then
Yes.
try and find a way to stick them on the car. You save yourself some time. Right? Put a couple beads of tape on there, run the sealant. It will stick to the metal.
Not
Give it a
just
quick
spreader,
tool.
not just spreader.
Yeah.
Right around it and call it a day,
Peel the tape.
and you're done.
And you're done. Because you've actually, now it's 100% bonded versus this manipulation thing of making pieces and gluing them on is kind of,
Sounds like a lot of work.
I don't like a lot of work. And again, depending on which sealer you picked, how much time you have to work. So if in doubt, go slow. Pick a slower one, right? Self-leveling seam sealers, there are some tricks, and you're always going to see self-leveling sealers on a horizontal surface for one simple reason. They're so viscous or thin when they come out, they'd run off on a vertical surface. So they've got to be kind of trapped or just on a flat so they can't spread too far. In our industry, F-150 is the big one for the, the wrap joints, the roof aperture joint, wrap joint. There are some neat tricks though when we go to use this stuff. Always want to store the cartridge upright for a half hour. Why? It's very thin material. You get air bubbles down through it. We want them to just float to the top. Then when we level the pistons, we'll do it in the same direction, vertically. Get the air out, get both A and B material coming through. Then we want to put the mixer on, and when we purge the mixer, so once you're ready to actually do the job, now we're going to purge the mixer in the vertical position, and we're watching. It goes real slow. We want to get all the air out of that mixer. So you don't need to run it out fast. Take your time. It'll take more air with it. The more air you get out now, the fewer bubbles you're going to have to deal with when you do the joint. Sometimes folks have a problem. The front and rear, where the roof rolls off, the material wants to run maybe off before it starts to set up. Grab a heat gun. Warm the roof up before you even prep the cartridge. Get the roof up to 120, 130 degrees, that's nothing. But get it warmed up. When the material hits it, it's an epoxy. We go back to that whole 70 degrees, 5 minutes work time, 90 degrees. Well, now it's hot. It's going to start to kick fast. Once you put the material on, and when you're doing these roof ditches, have two folks, right? Get the guy that works next to you to come help. Use a pneumatic applicator. It's a long run. You're going to get tired. But right where you start out, we can bring that heat gun into play right there and start heating it from the top too. We'll get it to kick.
Then sure the tip is in the material as you go down too.
Yeah, well, so we get the air out of the mixer. The only other way that you're going to get air in your seam is by pulling the tip in and out. Leave it submerged in the epoxy as you fill the channel. And then hopefully you can get your buddy to come by, and you can use the heat gun. You can use it with or without heat. You can use an air gun. You can use toothpicks. We want to, using the heat guns or the air gun, we want to shake the surface a little bit. Helps any bubbles rise. Sometimes you pluck them with a toothpick or a scratch awl or something. Get it to pop out. You want as many of those gone as possible. If there's one there when it locks up and cures, you're going to want to dig it out and fill it up. That'll pop in the paint process and leave you a little blemish. So other kinds of sealing, supplemental corrosion protection. Anything we haven't covered in seam sealer, we want to deal with via a cavity wax. And cavity waxes are designed, they do in fact dry, right? They flash off. There's solvent there that has to go away. But by the design, they creep and wick down into very tight areas. So if you've got a spot that you couldn't maybe weld seal, or you've just got maybe done some other welding, if you saturate it with cavity wax, it'll seal things up. Whenever you're doing any kind of welding, we always want the E-coat removed right around that area because we don't want any burn back. If we're going to be trusting the cavity wax to do its job, the paint has to be taken away from that area when you go into the welding process. The wand will let you get into cavities. You can always just spray it. If you were doing like a door, you could just spray it, but if you wanted to reach up through an access hole, this is how you're going to use the product. Get it in there.
Start to spray it, and then walk it out. If you don't think you have enough, do it again.
Yeah, and typically the method that's kind of taught is do it twice. Do the whole thing, let it run, do it again. A lot of philosophies about this. If it's not dripping, there's not enough in there. You really want enough of the stuff to let it do its thing and creep and go where it needs to go. Don't spray the window regulators. Don't spray an airbag, a seatbelt tensioner. If you got components in these areas you're waxing, take them out, put the wax in. If you don't, you're going to mess something up. You get it on a run channel, you just bought a run channel. If you get the car out of the shop. If not, it's going to come back when the window starts hanging up or you get blamed. Maybe they just bring a bill to you. You took it somewhere else and had it fixed.
Yeah.
While you typically use cavity wax on the underbody, I'm going to say it just because, keep it away from the exhaust. It is flammable. Even when it's flashed off, it's still potentially flammable. So, don't rust-proof your muffler. It's just not going to get you anywhere. And cavity wax, it's not like this is something just for collision repair. This is an OE process. BMW, Mercedes, Toyota, Lexus, many others use cavity waxes in different degrees on their products. I know for a fact that Toyota Lexus sprays the hoods and the doors. Just the bottom, and the leading edge of the hood and the bottom of the doors. BMW, every body goes into, after it's been painted, goes into a station, they connect to the rails, they actually pump 100 liters of warmed wax down through the car, through the rail system. And it's going through an oven, dripping. They reclaim 98 liters, which means
2 liters stay in the car.
2 liters in the car doing their job. That's why you get into them, there's always that wax in there. Then they do the doors and quarters. So when you're making a repair, some cars, to duplicate the original car, you have to do it. Why would you not do it? It takes minutes, it takes a little bit of material. Just do a high quality job. And this is really going to come into play in the northern climates where we've got road salt, right?
Yeah.
Don't fix my car and have it all rotted out in a year. It'd be like buying an old car. That's what they did because they didn't have anything in there.
None of that stuff. None of that. They didn't have any of that.
No. It all started, we started adding galvanized materials, if I'm not mistaken, back in the early 60s. And we've progressed, with a lot more E-coat and then more of waxes and other corrosion protection. So you just have to do it. You just got to do it. Don't miss the underbodies of the cars too. If you're working on a trunk pan and it's got some heavy coating, the one I always think of is the Mercedes and Dodge Sprinter, which have a PVC coating on the underside. You need to get underneath there with a spray of a 1K or 2K and rebuild it. Make it look factory, also give you the protection you need.
Or it's going to be very loud.
Yes, the stones will suddenly become louder.
It's one big drum.
So the last area of sealing is stopping air flow, movement, stopping noise, right? This is the NVH thing. You hear a lot about it. NVH references noise, vibration, harshness. Harshness is when it just doesn't feel right? If something clatters or it's just, you shut the door and it's tinny, it's just low quality. Vibration, that's from the drive line. So there's not a lot we're going to do that has anything to do with vibration per se, but the noise part, that's what we can really affect. And noise in a car is moving through the air. You imagine a car driving down the road, running into the air. Well, that air is going under the hood, under the fenders, and then it can begin to find ways to wick inside the car. We want to keep gases, noise, air movement, all to a minimum. We want to keep what's outside out, what's inside in. And we can do it with foams. We can do it with beaded materials, depending on where we're at. And this is a hard foam. If you press on it, it just doesn't, I'll let you do that. Here's a nice soft foam. So you typically see stuff like this in the pillars. You see these softer foams maybe on door skins, roof bows, places like that. Under hood, a lot on a hood, or even a deck lid. That's more of an anti-flutter, where that's more of a cavity fill. We've got a big area we want to fill so it really comes up. Keep in mind that the difference between what's in the car at the factory and these versus like a home insulating product, these are closed cell foams, where the home insulation stuff that comes in a can, that's open cell. And what that means is moisture can travel right through it. Closed cell, nothing can get through it.
So that open cell is like a sponge.
yes, it becomes, well, it's absorbing water first to cure, and then it just lets water come and go as it pleases. It can lead to a real problem with corrosion. When another thing we often hear, that I mentioned the tinny sound, you slam a door. Often this is a complaint after someone's had a door skin put on, they get the car back and they slam the door and like, it sounds wrong, it sounds funny. You know, this is where those outer skins, like on a door or a roof, it's almost like a drum, right? If they're allowed to move, you hear it. So this is where you're going to want to use some kind of a soft foam or a sound dampening material. And I'll talk to that in a second. But let's focus on where you find all these foams and then what you might use to repair them. Like I said, you're driving down the road, air's coming at you. The OEMs are trying to control how that air moves through the car. You really don't want it to get in to begin with. And or any noise that's created in the car, we don't want it to move around. So we don't want to go from the front to the back or the back to the front. Front fender rails, one place you'll see foams. The A-pillar, top and bottom, you see it. B-pillars, rockers, rear body panel. That's an area with some manufacturers, they put a ton of foam in.
I hear it all the time.
Yep.
I spend an hour digging out foam.
Well, you have to dig it out because it burns like crazy. But as you're doing that, notice what it is. Is it hard or is it soft and fluffy? You can also tell if you look and you see the foam's pushing out through these holes. They probably just poured it in. Per foam is one of the names for that. But that'll be like the Fusor 130, more the rigid stuff. Often what you'll find in the pillars will be these soft foams. Now it's trapped inside where you can't actually get in there. But if you look at it, there'll be a little piece of plastic that it's attached to, maybe a piece of steel. And it had a piece of, it had some chemical put on it in the factory. They clip this little piece in. When it goes through E-coat, it pops. Nickname is poppers. So you take this little piece, stuff it in the car, and when it comes out, it's that big. Those are usually soft. So when you're fixing those, if you have an access point, you could use the soft, flexible foam like Fusor 121, or you could use a sound dampening material. We just launched a product called 231, and the idea behind it is to give you something with a lot longer work time than a two-component foam, because they kick in seconds, and they're all done in 30 seconds.
It can be a challenge to work with in a tight area.
Can be. If you're putting a roof on, I need some time. So what this product allows you to do, it's got 60 minutes open time. Again, it's 70 degrees, but you can lay your panel in place and get it bonded down, weld bonded, whatever the process is the OEM's defining. It doesn't expand or contract. It's a non-sag. So what you end up not having is there's no read-through. This is the most critical thing. Often you'll see a repair done and you can see a line. Maybe you'll see it on a door where the intrusion beam is. Maybe you'll see it in the roof. And you'll see this shadow. That's read-through. You won't see it with 231. Other areas for sound dampening, Q-pads is one of the terms in our industry. You'll see sprayed in products, primarily in the trunk areas, also in the passenger compartment, but you don't usually see that, right? It's underneath the carpet and the backing. But you can use a sprayable product, get it in there, then you can use texturing, right? You can comb it, rake it, whatever it takes. Maybe it's just a spray-in texture, hammer it on. You just want to know what it is. If it's a softer product, you might see it in a door, you might see it in a fender. You can always tape those off, just spray it, get the right thickness, peel your masking, you've duplicated what the factory had. But if you find one of those patches on a fender or a quarter that are hard, that's a beta patch. That's there for another purpose. That's there to support the panel. It's an area that maybe oil cans, so they put the patch in that stopped that, or maybe I've heard on one of the pickup trucks, it was an area where the owner typically leaned. These are the things they know. The owner's always leaning there. People, that's where they stand and talk, and the fenders would pop in, slap a patch on. Those are a little different. You need to either recycle what was there, glue it on with some epoxy, or hopefully the service part came with a new one. So with that having been said, I want to thank you all for your time tonight. It's actually been a whole lot of fun putting this together.
Sure has.
It's been a blast, and if you've got questions, and you will have questions, there's always something coming up, reach out. 1-800-234-FUSER, Fusor.com. Get with your sales rep. Go to the Facebook, go to YouTube, ask questions. You know, if you don't have the answer, then reach out. Find someone who's got it. If you use the 800 number, I can pretty much guarantee that if they don't have the answer, eventually I'm going to answer your question. So I like those challenges. With that, Dennis, it's been a blast. Let's do it again, buddy.
Absolutely.
All right. Good night.